Okay, this video is going to be a brief introduction to Turtle Graphics. It's a Python 3 two-dimensional graphics drawing library. The first thing you're going to want to do when you are exploring a new library is to go to, or packages they're called in Python, you want to go to the official documentation. So we can find that here at docs.python.org/3/library and turtle.html. So this should be the latest version. Once you're on docs.python.org, you can usually select which version of Python you have. Usually the latest is what you want. Alright, so this is the Turtle Graphics package, and you can draw things like this and fill them in with colors and have outlines and different things like that. So we're going to start out today with a little file called intro, and the way you start all of your Turtle Graphics programs, you're going to import Turtle. And Turtle is the package or the library, and then we're going to say turtle.done, and done is a function. So the way this works is Turtle is a library, so this becomes an identifier that points to that library. What do we mean by a library? Well, a library just has a lot of variables and functions and classes associated with it. Okay, so this is the library object, and we use the dot accessor to access the things inside of it. So one of the functions that's inside of the Turtle library is the done method, and this basically just keeps the window open. All right. So what we'll do here is we will run Python 3 intro, and this should create a window, and this one's a little bit big because I have two monitors here and one's larger size than the other. But it creates this Turtle Graphics window here, and you see it stays open, and when I click the X then the program finishes. So it stays open because I added this line here, turtle.done. Alright, so the first thing I want to do is adjust the size of my window to make sure, especially in this situation, I have two monitors with different resolutions, so it's acting a little bit squirrely. So we're going to take care of that right away. First thing we do is we get the screen object. So we can get the screen object from turtle dot, and there's a capital SCREEN. Okay, so again, this is the Turtle package. The dot operator is the accessor. So we're accessing something that's in the Turtle package, and this is, it looks like a function, but it's actually a class. The way I know it's a class is by convention. Classes in Python always begin with a capital letter, and so this is actually what a class is a way to instantiate an object, to create an object. So I'm creating a screen object, and actually there's anytime you call this particular class, there's only one screen object. It's always the same screen object, where normally when you instantiate a class you can have multiple objects of that type. This is what's called a singleton pattern, and every time you call this there's just the one instance of the object. Okay, so so we have the screen, and then we need to call screen dot let's see, screen size. And what this does is sorry, there we go. This lets you specify a width and a height, right? And this is the canvas. So when we're drawing, when there's a concept of a canvas, and how many pixels wide and how many pixels high is this canvas. So we might want to put that here up at the top in some global variables. We'll say the width is 640 and the height is 480. And then we'll set the screen size to width and height. Now this is just the canvas size. There's also the window itself. The window itself can scroll, right? So the canvas size is what you can draw on, and then the window size we also want to adjust. So to do that, we say screen.setup and pass in width and height as well. Alright, so let's run this. And so we see that our window now automatically has resized, but we do see a little bit of scroll action here. We probably want to get rid of these scroll bars, so what we can do is tweak this window size so it's just a little bit bigger, and so then the scroll bars will disappear. Okay, so here, this again, we're going to remind ourselves here that this is the window setup, and then this one is the canvas. Alright, so the window setup, we will just add 10 to both of these variables. There we go, and that was just enough to get the window size beyond the canvas so the scroll bars didn't appear. Okay, so now we have a starting point. Now what we want to do is create a turtle. So this is why it's called turtle graphics. The idea of a turtle is basically a shape on the screen that animates and shows you how the computer draws the lines that you tell it to draw. Okay, so the whole point, or one of the points of turtle graphics, is to show you, to teach you how the computer draws things, right? And so sometimes that's easiest with some visualizations. So what we want to do is create one of these turtles, and you can call it whatever you want. I was a Ninja Turtle fan, so mine's Don, and we're going to use the turtle package and then the dot operator and access the turtle class. So it's capitalized, so that the classes, remember, are going to create objects, and this is going to create one turtle object, and we could theoretically have more than one. If we need multiple turtles drawing things on the screen, we can do that as well. Okay. And again, this is just a variable name. It's an identifier. You can call this whatever you want. Right? But that's enough. And we can draw this. And Python puts our little turtle. And by default, it's just a triangular looking thing. And by default, it has a direction, right? So the direction is pointing east, right? So that would be 0 degrees. And then north would be 90 degrees. And then west is 180 degrees. And then south is 270 degrees, right? So there's this concept of direction that's called the heading. So the direction of your turtle is called the heading. And I can close this. At any point, if I wanted to hide my turtle, and so I wouldn't see him, I can say don.hide turtle. I think it's hide turtle. We'll see. Right? And so my turtle's still there, but we cannot see him. Right? So if you ever get sick of your turtle, you can hide him as you're drawing. But we're gonna keep him around so we can see what's happening when we draw. Right? So there's a couple of basics. So the idea is the turtle has a pin attached to him, and if you go forward, so I want to go forward 100 pixels, the idea is he drags the pin behind him, he or she. And you see we actually have the line being drawn there. Now I do want you to be able to see this animation, so I'm going to do something special in the code here to add a little, I'm going to import the time library. And before we do any of this stuff, I'm going to say time.sleep, and I'm going to sleep for 1.5 seconds, and then that way when I run this, it gives me time to drag the window over, and then we see it move a little bit. I might need to do 2 seconds there, maybe 3, we'll see. Okay, 3 is a little bit long, but then you actually see the turtle drawing the line. Okay, so let's go for 2.2. That should get us. So this part is something you would not necessarily have to add. This is specifically for my situation because the window keeps popping up on my other monitor, and I bring it over. All right, so we see that there's a pin associated with the turtle, and I can move it forward. But then I can tell the turtle to turn as well. Like I said, the turtle has a direction. So it starts out with a heading of 0, and I can say don.left 90 degrees, don.forward 100 pixels, And, oops, gotta close my window. Run it again. Okay, so he goes forward, then he turns left 90 degrees, and then goes up. Alright, so I could make a square pretty easily. Don dot left 90 degrees. And then duplicate these lines. Right? Now notice I'm only turning left 3 times here. Okay, so he ends up back where he is, but one thing that's important to remember is that now his heading is facing down, where originally it started out to the right. So if I want to stay consistent, I could do a Don dot left there as well, and then he will be facing the same direction he was when he started. Okay, so that's a nice easy way to draw a square. And we could do this, of course, in a function. We could define a square. We could have a width and an x and y position. Right? And what we want to do is so the width is going to be, you know, the number of pixels that we go forward, right? But how do we change the location of the turtle in the x and y coordinate? So the way the coordinate system works in turtle graphics is, let me comment this out. You have a coordinate system here, and it's just like a Cartesian plane in algebra, basic mathematics, basic graphing. You have a coordinate system, an x and y coordinate, and 0, 0 is in the middle. As the x coordinate goes up, the location goes to the right. So if I'm talking about something on the right half of the screen, that's going to be a positive x value, and the further right I go, the larger the number. And anything on the left-hand side is negative x. Similarly, as you go up, anything positive y is up, and anything as you go down, anything or that's negative y, right? So the higher the value, the farther you go down to negative y. So there is a special function called goTo, and I can change the location of my turtle. All right, so let's say Don.goTo, and I want to go to the x and y coordinate I specify here. So x and y, and then I might want to draw my turtle, but then I'm going to use my width instead of 100. Now I'm still gonna turn left 90 degrees each time. Okay, because that's what a square is, right? It's all sides of the same length and 90-degree angles. So that's how it's a square function. So I can call this function, and let's say we want to put it. We're going to put it at negative 100, so that should be on the left-hand side, and then positive 120, and then we'll make this a little tiny or a small square of 50 pixel sides. All right, so we can run this. Square. Oops. There we go. Okay, now notice the turtle had the pin down, and we called the goTo function, and so it went to our new location. This location, Don.goTo x and y. This location is negative 100, positive 120, but the turtle's pin was down. So what we want to do, there's a function to put the pin up. So Don.pin up, and there are shortcuts for these functions too. I think you can just call pin up, but or Don.up. but I'm going to use the longer names of the functions as we start out here. So if you say don.pinup, then when you move Don with this goTo statement, then you can say pin down afterwards. So that way when you move him, he's not going to drag the pin with him. All right, let's close that and run it again. So you see he did not draw his line to that after that or to the goTo statement, because we lifted the pin up and then we put the pin back down to draw the square. So one thing we might want to fix here is the X and Y coordinate we're specifying. It seems like the way, just it happens to be the way this has worked out, that the X and Y coordinate we're specifying is going to be the bottom left corner of our square. Well, we probably want the X and Y coordinate to be the center of our square, right? So if that's the case, then how can we do that? Well, we have to figure out what we would do if we wanted this to be the square to be in the center, right? So we go to the location that's the center of the square, but then we'd probably want to come down half of the width. So the turtle would then come down half of the width, and then maybe go to the left half of the width, and then start drawing the square, right? So let's see if we can do that. So instead of going to X, we're going to go to X minus width divided by 2, and then we're going to go to Y minus width divided by 2. And we'll see if that gets us where we want to be. Oops. What was that? Okay. Let's take a look and see if we put it at 0, 0, if it's more obvious if this is working. 0, 0. There. So you see it started out there, then we went down half of the width, left half of the width, and then we drew our square. Okay, so now when we specify that, when we call the square function, now X and Y is going to be in the center of that item. So that's entirely up to you how you do that. If you were okay with drawing the square and having the square X and Y coordinate be the bottom left of the square, that's fine. But generally speaking, people are probably going to assume that you specify an X and Y, it's going to be in the middle of the object. So that's why we did that there. But you could see we could do that with just some simple mathematic manipulations, or arithmetic, right? We take the X value and then we subtract the width divided by 2, Y value, subtract width divided by 2. A couple more things and we'll be done here. Something you can also do is play with the colors, and you can fill in these objects, right? So we have Don.pin size. So that's going to adjust how thick of a line you have, and it starts out at 1, so we can do something like pin size 6, and then that's Don, and then we can say Don.pencolor. Now with color, there's several built-in colors you can specify, like red, or you can also specify custom colors. Don.pencolor. We want a fill color here. So we'll do the fill next. We'll start with pin color red, and let's just run this again, and then after that we'll do a fill color. Okay, so the width of the line was much larger, and the color now has changed to red. Now what we want to do next time is, let's put this back to 1, we'll set the pin color back to black, and then we're going to have a fill color. So Don.fillcolor, and you can specify a fill color a couple of different ways. One of the ways is with a hash RGB color code. So the way this works is there's 2 digits of hexadecimal values for each color, R, G, and B, red, green, and blue. And so hexadecimal color or digit goes from 0 to F. So F is 15. So it's a number system thing, like we use the base 10 numbering system. Hexadecimal is base 16, and it just allows you to write more numbers in a smaller number of digits. Okay, so we have 2 digits, so FF would be the highest. So if this is the amount of red, which is all the way up, and this is the amount of green, which is all the way up, and this is the amount of blue, which is all the way up, and so all of them together, all of the light channels all the way up, makes a white color. And so I'm using the Atom text editor, and there's a plugin called Pigments, and whenever you specify one of these color codes, these hex color codes, or hash color codes, it will show you what color that represents. So we can see that if I have 0 red, 0 green, and 0 blue, that's the color black. And if I just had FF and the rest 0, that's a full red channel. If I have red and green, that gives me a yellow. If I have red and blue, that's a magenta. And then that would just be blue, right? And so you can play around with these colors, right? You can try to figure out, you know, what color you're looking for. Let's say we wanted some sort of, you know, a dark brown maybe. We might do like, you know, an 8 of red, 6 of green, and 1 of blue, something like that. It's kind of yucky. Let's add some more red. There we go. Let's get rid of the blue. Let's see, we'll bring that down. That's a little bit too much red. But see, as you can see, you just kind of play around with it, right? I'm fiddling around with the amounts of red and green and blue. There's a nice darker brown, right? So that might be like a tree bark or something like that, right? So you can play with these colors. We'll go back to just a bright red, but we could, instead of specifying this hash code for the color, we could just specify red in this case, like that. But I prefer the hash codes because you can kind of play with them a little bit. All right, so you specify the fill color. So how does it know what to fill in? So once you've specified the fill color, you have to say your turtle dot begin fill before you start drawing any lines, and then after you've drawn all your lines, you want to say done dot end fill. Okay, and so then we can go back and we can see what this looks like. Close that. Okay, so the pen size went back down to 1 pixel, and it's back to the color black, and then the fill color is red. Right? So that is a basic introduction to Turtle Graphics. There's a lot more you can do, but hopefully you can play around with some of this and you know, start making interesting things and start understanding how the computer draws things. One more quick thing that we can add to our turtle is we can change the speed. Speed. They did the speed sort of weird. 1 is the lowest setting, and then 10 is the fastest, but then also they added another one later, I think, and so speed 0 is really the fastest. But you still see the turtle animating. There is a way to make it so that you don't see the turtle animating, and all of the items you've drawn just draw extremely quickly. So that has to do with the tracer. You can turn that off. So move this over here. And you see how fast it went that time, right? So that's with Dawn speed of 0, or turtle speed. All right, so that's enough for one introductory video. Hopefully you learned something and you can play around with Turtle Graphics.